So this is number 26 from chapter 4. Write the balanced net ionic equation for each that will occur in the following cases. Identify the spectator ion or ions in each reaction. So in letter A, we've got chromium sulfate, a 2 here, a 3 here. And then we've got some ammonium carbonate. Arrow, swap the cations. The chromium goes together with the carbonate. Chromium here is positive 3, and I can tell that because sulfate's minus 2, and there's 3 of those. There's 2 of those. So the positive 3 chromium goes with the minus 2 carbonate that you memorized. So make sure that you have 3 of those and 2 of those when you write the product, chromium carbonate. And then the ammonium right here, NH4, which is always positive 1, is going to go with the sulfate, so we're going to end up with SO4 over here. Sulfate, of course, is minus 2, so make sure that you have 2 of them. Notice when I write the reaction, I make sure that I have the charges balanced out over here first before I go and balance the chemical reaction. Now, to balance the chemical reaction, it looks like I've got 3 carbonates right here, so I'd need a 3 right here. That gives me 6 ammoniums, so I need a 3 right here to give me 6 ammoniums right here. 3 carbonates, 2 chromiums, 2 chromiums, 6 sulfates, 6 sulfates. Good to go. Alright, now I have to go through and look at each of these products right here and decide whether those are soluble or not, which one's my precipitate. Turns out that looking right to left here, all ammonium salts are soluble. So ammonium right here would be soluble, so this would be aqueous. I'll have to split that up because that's a strong electrolyte because it's a soluble ionic salt. Chromium carbonate, it says right here, all carbonates are insoluble except for group 1A elements in ammonia, and chromium obviously is not in group 1. Chromium's right over here. So that means this is going to be my solid, that's going to be my precipitate. Do not split that one up. Alright, now we go to the split part where we have to break it up to be ions. These are aqueous because they told us they were aqueous right here. And so this one is going to break up into 2 Cr positive 3 and 3 SO4 minus 2s. This one, don't forget to distribute the 3. It's going to be 6 NH4 pluses and 3 CO3 2 minuses because the 3 distributes to each of those species. Remember, keep the 3 with the CO3 because that's a polyatomic ion. On the right hand side of the reaction, we're going to keep this together, Cr2 CO3 3, and then distribute the 3 right here, so we'll have 6 NH4 pluses and we'll have 3 of the SO4 2 minuses. The things that cancel are the SO4 2 minuses and the ammoniums, so this underlined portion would be my net ionic equation. That's letter A. Letter B, we have barium nitrate, 2 right here, aqueous, and then that reacts with potassium sulfate. Swap the cations, we end up with barium sulfate. Barium's plus 2, sulfur's minus, sulfate's minus 2. And the potassium nitrate, so KNO3, potassium's plus 1, nitrate's minus 1. Balancing the reaction, I need a 2 for the nitrate right here, and there's a 2 right there for the potassium. Now we're balanced. Now we need to look at each one of these and decide whether they are soluble or not. So sulfate, barium sulfate. The sulfates first, all sulfates are soluble except for barium sulfate. Oh, okay, so that's going to be a solid right here. And then potassium nitrate is doubly soluble because all nitrates are soluble, and then potassium is also in group 1, so that's aqueous as well. Alright, got to split them up now. These 2 are aqueous because it tells us so right here in the questions. So this is Ba positive 2 plus 2 NO3 minus. Notice how the 2 goes right out in front here. 2 for the K, so 2K plus SO4 2 minus. And then over here on the right hand side we end up with barium sulfate solid. And then 2 K pluses and 2 NO3 minuses. The thing that's canceled are the nitrates. The potassium's also canceled, so the barium plus the sulfate ends up with barium sulfate is my net ionic equation. Last one, iron nitrate. This is going to be iron 2 nitrate. I can tell that because nitrate's minus 1, and iron then would have to be plus 2 to balance that out. And then that's going to go with KOH. Swap the cations. Iron goes together with the hydroxide. Iron's plus 2, hydroxide's minus 1, so it's FeOH2. And then I end up with KNO3 together. Potassium's plus 1, nitrate's minus 1. Balancing the reaction, I need a 2 right here, and I believe I need a 2 right here to balance out the nitrates. Now I go through and decide whether these are soluble or not. Potassium-containing things, they're in group 1. Nitrates also, so this one's doubly soluble, that will be aqueous. And then this guy right here, all hydroxides right here are insoluble except for group 1 elements, and iron is not a group 1 element, so this is going to be a solid. Split everything else up except for the solid, so Fe positive 2 plus 2 NO3 minuses plus 2K plus 2OH minus. Make sure to distribute the 2. Leave this together, FeOH2 solid plus 2K plus 2NO3 minuses. The things that cancel are the nitrates and the potassiums. The remainder right here is the net ionic equation, number 26.